everyone, I'm Vicky, I'm a computer engineer, and today I'm going to talk to you about how data science revolutionizes the world of predictive maintenance. So what is predictive maintenance? Predictive maintenance is the science of knowing exactly when a machine is going to break, or an engine. When I first started working on this project, I had nothing to do with engines or machines or, God forbid, maintenance, so I had a lot to learn. And the first thing I decided to learn, among a lot of other things, is how maintenance is performed in the Navy and in other places that rely on big machines. So the first thing you do when you do maintenance is preventive maintenance. We all have cars, right? When I need to take my car to the shop, I know that every 20,000 kilometers I have to go to the shop, and the guys at the shop, they go over a set of actions, and they're supposed to prevent any faults from happening. But we all remember this one time where we get stuck on the way to a really important meeting, and we couldn't make it, so that's when breakdown maintenance comes in handy. Breakdown maintenance means we couldn't prevent the fault, so now we have to find a fix for the fault that's already happened. So when it comes to cars, it's not such a big deal because we'll have to take the bus for a week or miss a few meetings. But when it comes to ships, it's a little more serious than that. Because when a ship can perform its missions, then other ships will have to perform its missions for it, and then we have to find spare parts in order to fix the problems within the ship. And when we get the spare parts, then we have a lot of technicians that we have to shift from whatever it is they're doing in order to fix this fault. So it's one big mess. So preventive maintenance doesn't prevent all types of faults, and breakdown maintenance is just the worst case scenario. That's when the world decided to work on something called predictive maintenance. And predictive maintenance is just as it sounds. It's supposed to predict faults before they happen. And like many amazing things that have happened in the world, the field of predictive maintenance began somewhere in the beginning of the 90s in NASA. A bunch of mechanical engineers were sitting around the table and yelling at each other that they're losing money over maintenance routines. And the way that NASA did it, and many other companies that rely on mechanical engineering in the world did it, was using physical models. Which means you have to have a really, really strong domain expertise in mechanical engineering. You have to know exactly how the engine behaves, and you have to know exactly how it changes its behavior according to any type of scenario. That's how you build a good enough rule-based model. But we're all software ninjas here, and we know that machine learning can maybe help with that. And you're right, a lot of companies in the world have seen this market and decided to pull through. And the way they do it is moving from rule-based algorithms to RUL-based algorithms, which means we're trying to predict the remaining useful lifetime of the machine using machine learning. So it sounds like a straightforward regression problem, right? But it's not, because in predictive maintenance, there are a lot of things that we have to keep in mind. The first thing is that we can face a very serious problem of class imbalance. We have a lot of data regarding very healthy and good engine data, and a lot less data on degrading engines or faulty engines. Just like click prediction problems, if you know them, in advertising. You have a lot of people who don't press the ads, and a lot less people who do. The second thing is that we can't just go and scrape the web if we want more data into our data sets. We have to have actual sensors that sit on actual engines in order to scrape, in order to get more data. So there are a lot of ways to gain more data. We can maybe take the car every 40,000 kilometers to the shop instead of every 20,000 kilometers. And that way we can win some free faulty engines data. And the last thing that we have to keep in mind is that we always want to make our models as accurate as possible. But in predictive maintenance projects, it's really important that we leave the lab as soon as possible and test our models on real-world scenarios. When I was a teenager, I always used to take my parents' car, and I was really, really scared to get stuck somewhere. And they didn't have a Tesla, unfortunately. But today, it would really, really help me a lot if I would take the car and know exactly the mechanical state of everything. It would really have made me calmer. So it's not something I have to dream about. It's not something of the future. It's something that's happening right now. Predictive maintenance is happening right now, and it's the most important aspect of a worldwide revolution called Industry 4.0. And these projects of predictive maintenance, they're super cool, and I invite you all to come and do predictive maintenance with me. Thank you.